Welcome, everybody. We are working on Unit 1 tonight, and we are going through our first PowerPoint here that comes from Intel Corporation, covering the materials for the first unit, and go through some of their standard slides here. Here's our overall agenda for this slideshow, and we're going to focus on these four topics at the bottom. So if you guys are wondering, like this stuff is, as I mentioned earlier in the class, this is built directly on Intel's internal training materials, right? It's heavily vetted. They've been doing this for quite a while. They got prompted by the US government to kind of push it out to the public and to the technical colleges. I think it's really well put together. I try to get into the flow of what they do. There's some slides that have a lot of content on them. Some of them are kind of superfluous. So if I'm kind of like bumping through them really quick, it's by intent. It's not that I'm trying to skip anything. But these are kind of like what we're shooting to get here are some of these skills. This is the first in a series of several courses that they've built that we have fully incorporated into our curriculum here at Gateway. These are the skills you're going to walk away with when we finish this course, by the way. Some of the things that we do, right? So yeah, quizzes, presentations, and discussions. So we'll talk a lot, and some of that talking really will be kind of dependent on material. You will find, and I think this is pretty normal, you'll hit on some topics, and we'll talk about them a lot, and other topics, and we'll go, oh, okay, yeah, interesting, and then move on. So let's kind of address some of the key issues, because when we start talking about AI, there are a lot of misconceptions about what it really truly is, right? And some of the things that we think about being AI sometimes are not, right? And I would always have this discussion with some of my faculty, and I would say, is it AI or is it just really well-written software? Is it really intelligent, right? And I would even contend that even some of the generative AI engines that we have are not necessarily actually very intelligent. They're just really well-written pieces of software that feign intelligence, right? So what is it? Why? Where did it come from? And then how are we using it in the modern world? So there's this guy, John McCarthy, we're about to learn about, who's one of the originators of the concepts here. He called it the science and engineering of making intelligent machines, right? Well, I think what you'll find most astounding about this guy is when he kind of came up with this. All right. So remember I was talking about Photoshop just before we started this? Like one of the really first, and it's kind of cool that they put this at the forefront here, is for me, I know a lot of people use like ChatGPT and go, wow. But for me, it was the products that were embedded into the Adobe Creative Suite that blew me away. Like I did the explanation of how I used to take images for e-commerce sites and trace around them and get rid of the background and do all these steps to make them look good. And it's spent an hour on each image. And then they came out with this, AI tool where I just ask it to do a task and it just doesn't. It does it better than I could ever do it, and does it in 5 seconds, saving me, hours of my day, right? If only I had the tools back then, right? What about, using AI to do stuff like that's really practical? Like, for example, using AI to predict when traffic jams are going to happen, how to prevent them, right? Have you guys ever used the GPS on your phone and you're driving, and then it's like, you know what, turn off here and go that way instead, right? What are the other reasons I use, like GPS, and I don't know if it's AI or once again well-written software, like, and I do this in Chicago a lot because I learned my lesson. Like, I know how to get there. I don't need the GPS, but I use it anyhow because it tells me where their automated traffic ticketing systems are located. Because they have like if you go through a red light, it just gives you a ticket. You get it in the mail a couple of days later, and I can tell some of you are smiling because that's happened to you too. Or speeding tickets the same way. It'll warn you where that stuff is, that kind of thing. And so why? All right. So, this is a really big question. look at some of the products that they're talking about here. So for example, chatbots, okay, or like, okay, they're using Alexa as the example, but what about like Siri or the Google Assistant, right? Have you guys ever used those tools? Or like when you talk to your phone and say, hey, Google, when does Costco close? That kind of thing. And it talks back to you. Is that really intelligent? Or have you ever gone to a website to get support? And I've done this, and I think it was like Spectrum for like, modem support or something like that. Did you guys hear that? My phone heard me and responded, and I didn't even tell it to respond. Right, okay. I'm a little scared. So my phone is listening. So if I say, hey, Google, how long does it take to get to Chicago?
Chicago from Milwaukee is 1 hour and 44 minutes. You can see the directions here.
I gotta say, dude, yeah, the response now, I mean, even when it comes to rare things, because I swear they hear me say the words and then I go to Google it. And even on Google now, I mean, sometimes like I'll have my next sentence was what I needed to type in, but I just said it out loud, and there's absolutely no way they could have made that connection without it listening. There's no way.
And I want you guys to be highly aware of this. When you allow these apps on your devices, and it's their phones which are most notorious for it. Google or Facebook Messenger is very notorious for this too. You got that app loaded up on your phone and you're running it, and you start talking about this or that, and all of a sudden you got a Facebook, you got an ad for it, you got a link to it. Yeah, it's kind of scary stuff. My point with this though is a chatbot necessarily intelligent? I went to get support from Spectrum once, and it took me a little bit, but eventually I figured out, oh, this isn't a real person that's chatting with me. It's a piece of software. And I asked it, are you a piece of software? I said, connecting you to an agent. It's like, oh, dang, they got me, that kind of thing. Here they have some other examples too, like Snapchat. If anybody ever used like the filters there, right? Like you can, and Facebook does this too, right? Look, it'll auto tag you because it recognizes your face. Yeah, that's pretty weird.
I think
Have you
that's
heard of the
illegal now. I got when I lived in Illinois for a couple of years after I moved back here, I think it was like $450 from a settlement for like because the Illinois had made it illegal for I think they call it biometric data or whatever. And I have no idea how they found me to give me the money, but it was definitely appreciated. I had it on my fridge for a long time, but I did cash the check.
I'd like to hear more about that. Do I have a check coming too, Charles?
I hope so.
All right. So why do we use this? I mean, the concept is right. So a lot of like companies do this, and I don't know how comfortable I feel about this, right? So a lot of people hate insurance companies these days because when they process your claim, like most claims get rejected. Why? Because they use software to just like, if it's not like the right stuff's not on the form, it just auto rejects it. They don't even have people look at it anymore. They use software to do it, right? Well, from the company standpoint, that's great. It saves time, saves money, right? They're not paying any money out. But right, so okay, improves accuracy in decision making, and for example, intelligent offerings. How about like the transcription thing? How many of you send a text message by using your voice? Or did like the searching I just did, right? Well, okay, full disclosure, I was very resistant. But then when you're driving and you see like, oh, I can send a text message to my wife and just tell my phone to do it, and I don't have to worry about like, hey, honey, I'm going to be late, and then it reads back the response. Oh, no, you're not. We got a thing to do tonight, or something, right? But yeah, seemingly intelligent. One thing, and we see this, it's just kind of funny because we use the Gmail system here at Gateway, right? And when you guys are typing up an email and you put somebody's address into the address bar, and then you go to type your message, is it already typing in like, hi, Joe? That kind of stuff? Or you're typing a phrase that like everybody speaks in, like, if you have any questions, please let me know, and you just hit tab and it's like kind of auto doing it. But also like these tools, like a lot of it, we've been using actually for a while. So think about like Microsoft Word. Like you mistype a word, it underlines it in red, and then you right click and it gives you the suggestion to fix it. Is this AI? Heck, think about like back in the 90s, Microsoft Office and Microsoft Word had that little assistant called Clippy, right? And a lot of people make fun of it now, right? And that was like their attempt, but was it really intelligent, right? The difference in the modern era is some of these are becoming AI driven as opposed to just being software driven. Ultimately, there's still computer programs that are driving. So this John McCarthy guy that we saw in a previous slide, he coined that term back in 1956. So the concept of artificial intelligence as a concept, right? He developed it. How many years ago is that, folks? 70 years ago, right? When they barely even had transistors to put in their computers. So the concept's been around a long time. A real weird thing that we have available to us, and I don't know how many of you have ever heard of this before, but there's a guy named Alan Turing who was, and we'll have another slide on him here in just a second, developed this thing called the Turing test, which basically is a test to determine, kind of like I did with my chatbot with Spectrum, to figure out, hey, I'm not really talking to a person here. I'm talking to software, right? Because when I throw a nuance at it and it couldn't handle it, you know, like a person would, right? But he described these concepts back in 1950. So now we're going even farther back, right? And the point is, you know, the Turing test is basically that you ask computer software programs, machines, whatever, a series of questions to figure out, is it a computer or is it a person or an intelligence that you're talking with? And when we get to the point where it is indistinguishable, that's when we have to start to worry. I think that what about Skynet, right?
Have you heard of the dead internet theory?
Yes.
Yeah, that is absolutely terrifying to me. I wonder how many fights have been started with a bot, and like they really think they're fighting with somebody and it's just manipulation. It's crazy.
Yeah, there is. And what Noah's referring to, folks, if you're not aware, is how much content, like especially on social media sites, is not generated by humans. This is really scary kind of stuff.
And how much conversation we're having with that we believe is people, and it's not at all.
Yeah, and you know what? It's kind of normal, you know. And there are people who already like use their Chat GPT like their friend. Noah, you might be one of them, but you're paying for it.
Oh, dude, it calls me out, man. That's actually what gets crazy. After you use it for a couple months, it absolutely keeps a log of things you've said 2, 3 months ago. And if you contradict yourself, it'll let you know. Like, hey, this was your plan 3 months ago. Are you sure? Like,
October,
hey,
you said you like pizza. Now in
right.
December, you ate it.
Yeah, it'll catch things like that. Your language, how you speak about yourself, even. Like you can analyze how you type and get feedback on yourself. Like, hey, am I using destructive language or healthy language when I'm speaking about myself? It's really interesting what you can do with it.
See, I always thought that's what wives were for, but you know, maybe I'm not.
Uh-oh.
Bad joke, bad joke. All right, so John McCarthy has a couple of other really notable contributions. First of all, there's this language that he developed called Lisp, which was one of the first, you know, they call it a symbolic computation, but it was also one of the first object-oriented languages in use. Very ironically, my wife's uncle on her mom's side used to work for the Livermore Laboratories in California and used to program satellites using that language. And when he quizzed me on it, he goes, did you ever hear of Lisp? That's my language. I'm like, yeah, that's John McCarthy. And he's like, he was impressed that I even knew it. But once again, he coined that term. You can see some of the things that he was awarded, right? So he had a lot of really notable contributions to the field. You know, here's a picture of him, right? And I always find it kind of interesting. Look at that, like really fancy computer he's working on. That's probably, you know, I'm going to say late 70s, early 80s, you know, kind of technology he's using there. But look at the quote. I don't see that human intelligence is something that humans can never understand. right? So this is really kind of an interesting little thing to think about, because if we can quantify our intelligence, then we can start to simulate it and code it and build it from scratch, right? With intelligent design on top of it all. So this is a picture of Alan Turing, right? And any of you that have had the Python class with me, you guys remember the computer history thing, and we talked about like the abacus and then the Jacquard loom and Charles Babbage and IBM and punch cards and then mechanical computing devices. And by the time we got into the 30s and early 40s, both Germany, Britain, and the US were building electromechanical computers. They were a combination of electronic components and gears and widgets and stuff that you could pump or program formulas into, mostly math, and then generate responses from it. John, you have your hand up, I see.
Yeah, just a quick question, probably unrelated. Anyways, did you mention Livermore? The Livermore laboratory
in California.
Did you by chance thought of, or you related to Nicholas Christophilus?
No.
Okay, because it's amazing that you said that, because anyways, I was reading a book on DARPA. I've been reading a book, haven't finished it. And I came across this scientist who started from scratch he was a elevator engineer in Greece and eventually moved to the States and became an employee, or was hired by what became as, they renamed it to Lawrence Livermore National Laboratory. It used to be Livermore only. Anyways, but I don't know what you said that helped me, or I made the connection. So because of your background, your ethnicity, whatever, I thought of him, and I don't know how I made the connection actually, but it's something you said. And he was from the 1950s, 1960s, after the war ended. But anyways, he was an amazing scientist. I don't know. He worked for DARPA, the agency in charge of various projects for the Department of Defense and different groups in the armed forces and CIA, FBI, and so on and so forth. Anyways, sorry for the detour.
I like the sideline actually, because a lot of the stuff that really was often developed because of either people being really brilliant trying to solve practical problems, right? And often for defense reasons, so that somebody else didn't pull us up first, right? Which is where Alan Turing came in, right? So like, if you guys remember the whole Python speech I did, about the computer history, and this is where, once again, we have all these like tight connections to real history in this area. If you guys ever go to the Museum of Science and Industry in Chicago, and you go and you see the submarine that they captured, right, the German submarine, all the German ships in the Atlantic Theater would carry what they called an Enigma machine, which basically looked like a typewriter, and every 24 hours it would update its cipher, and basically you would type a message on it and then it would like turn it into something else, and then that's what they would broadcast over the radio. And Alan Turing was on a team where they built an electromechanical computer to intercept those communications, and then they would have a 24-hour period to try to crack the encryption, right? And ultimately would burn them, as every transmission would end with Heil Hitler, and that became the key for them to solve the encryption, right? And eventually they cracked it, and it was, by many people's accounts, the thing that allowed the Allies to win the war. It was a turning tide. When they captured that submarine that you can see in Chicago, it had an Enigma machine on board, and you can walk right up to it and look at it, and it just looks like kind of like a typewriter. And his machine and the mathematics that he put behind it was what cracked it. And he's the one that came up with this Turing test that we're about to talk to. And you can see 100 most important people of the 20th century. Yeah, he's way up there. He's really, really notable. Unfortunately, he was also a homosexual and heavily treated very poorly by the British government as a result. Like he was, yeah, kind of like chemically castrated, and it was horrible, right? If you read up on his story, if you guys ever see the movie The Imitation Game, it's about that story, and it's an excellent movie, just as a movie, historically, but the fact that you tie it into mathematics and computer history, I mean, is very, very fascinating to read and to see, right? And so, okay, once again, the Turing test was really, really important to the field of artificial intelligence and this concept, right? And notice what they call this the imitation game. So it doesn't come from anything. So here's kind of the basic concept. So pretend like you're playing this game. You got three people playing, and you assume one person's a man, one person's a woman, and then the person asking the questions is somebody else asking the questions, right? And basically what you do, player C asks the others questions to try to figure out, are you a man? Are you a woman? What are you? Who are you? What are you? And tries to figure out if they're telling the truth or lying, and trying to figure it out, right? So, all right, so let's just kind of move past that. All right. So player A's role is to trick the interrogator into making the wrong decision, right? Player B attempts to assist the interrogator in making the right decision. So like one person tells you, no, I'm the man. No, he's not the man. He's the woman, that kind of thing. All right. But then what happens if you take player A and replace it with a computer, and now you think you're talking to a person, but you're really talking to a machine? Now, I want you guys to keep in mind that he conceptualized this before we had any of the technology that we're using today. Yeah, that's what blows my mind, right? These guys are thinking like a century ahead of most people, like way ahead, right? And what if player B, replaced by a man rather than a woman, tries to help out, but they're still false also? That's kind of the point, right? So is it true that the computer, okay, is it true that modifying, right, the computer to have adequate storage, increasing the speed of its action, providing it with an appropriate program? So in other words, the computer's got to be able to have enough horsepower to actually simulate being a person. Weird. I think we're finally starting to get to that point, but I don't even think we're quite there yet, but we're getting there. Okay, so player C can satisfactorily be made to play the part of player A in the imitation game, okay, while player B is replaced by a man. Okay, this is like some deep stuff, right? All right, so what they normally would do is, like when we did the training, they actually made us do this. Like we went into roles and we played the whole thing, and we really don't have time to do that, unfortunately. But normally, here's what we do: we'd split into groups, we'd follow those rules, and we would try to trick each other. And I'm not sure how you would isolate yourselves, right? So you would have like a list of questions that you would generate. You'd have groups of humans, groups of computers, and groups of interrogators, and you kind of go through it. All right. I think it's fascinating though, because the Turing test basically has become boiled down to this: questions that you can ask what you think is a human to determine that it's actually a computer, right? And I think that's really profound in an era where they didn't even understand what AI was. And the fact that he conceptualized this so deeply, so far in advance, really truly blows my mind. Now, here, and I think this is kind of an interesting slide too, they start talking about how some of the technologies were developed. So in other words, some of the coding concepts that help, for example, to build neural networks. A neural network, in essence, is software that's built to replicate the actions of the human brain and its wiring, right? And they started writing software like this back in the 50s, right? Based upon these concepts, and that work continued well into the 70s. And a lot of really notable IT people like Richard Stallman, for example, back in the 70s worked at the MIT lab of artificial intelligence. And it's like, they had AI back then. Yeah, they were working on neural networks. They were working on these problems back then, albeit with primitive technology, but they were still working on it. Right? They knew it was coming. Right? After we get past kind of the mid 70s into the early 80s, then they started developing software that we now call machine learning. And what we'll learn, and you see the little diagrams that go with it. So like neural networks try to simulate the connection of neurons in the brain. Machine learning uses more kind of like the concepts of logic, true, false, and formulas to ration through decision trees to come up with the best solution for a situation. And it often is, it's not quite a neural network, but it follows these mathematical things. And we'll take a look at some examples of that in just a little bit. And the concept is that you program the machine to perform certain tasks, and then given certain scenarios, it can automatically adapt to it given the scenario. And you don't have to do anything to control it. So in other words, like a car driving down the road, oh look, there's a pothole, steer around it. The machine learning can figure out how to do that on its own, right? If you give it the right algorithm, right? So it's kind of teaching itself, right? Now that we've got significantly more processing speed, storage capability, bandwidth, more powerful chips, et cetera, et cetera, et cetera, et cetera, we're into the point where we are into what we call deep learning systems. It's taking like machine learning to another level, and cognitive systems where we're combining the neural networks with the machine learning and getting to products that are like ChatGPT, right? That simulates almost the cognitive power of human beings. And if my contention is true that we're just at the precipice or the beginning of this, where is this going to go in like 10 years? Like, holy cow, right? Scary stuff. Now, in terms of like where generative AI sits in this, generative AI is actually kind of a subset of machine learning and deep learning. That's kind of what the graphic is showing us here. So it really is an extension of that technology, right? And I think that's fascinating that, it was kind of put together that way. Neural networks, basically, originally conceived, and once again, look at the dates on this stuff, right? It just always blows my mind. Do you guys remember the ENIAC computer system that, the first fully electronic one? What year did that come out? You can look, Noah's already on it with ChatGPT. 1940. See if
I was actually looking up, I'm trying to figure out IBM's Watson, how many connections that thing has, how many human connections there are.
Yeah,
I was digging
let's
into
not
that.
let's not worry about
Sorry
that.
about that. What did you want? What was it?
But ENIAC, the first fully electronic programmable computer, was in 1946. Right, it was one of the tools that we used. Charles?
The first, so I looked it up and they're sort of fuzzy on what they call the computer, but the Mark One from IBM, which is at Harvard, it started in 43, but it was operated by the Defense Department at first. It was used for ballistics calculations.
Yeah,
But
there's a few major ones that were developed right around that time, but the conception for the neural network, to simulate how a brain works, 1943, right? And it was not done accidentally, because what they realized is that the brain has this ability to solve problems. And if we could simulate the wiring of the brain through programs and technology, maybe we can solve problems like the brain. Because you have to admit, human brain is a pretty amazing and powerful thing, right? And then here's images of these people that developed these concepts. It's kind of interesting just to look at them, right, and go, oh, that guy, okay, right? If you would maybe dismiss them otherwise. We also have the machine learning area. And once again, machine learning really rests very heavily on mathematical concepts. That's really where it draws from. So they give some examples here, like given the history of home sales in the city, you could use machine learning to create a model that is able to predict how much a different home in that same city might sell for. And it's not accidental. It is built upon mathematical formulas. Now, believe it or not, right? Like if you hire somebody to appraise your home to see like what it sells for, right? Or if you're buying a house and you hire like a home inspection person, I mean, how do they figure that out? Well, they look at what other homes sold for, what features the house has, what shape it's in, what neighborhood it's in, how far it is from the fire department, is it close to schools, is it convenient to shopping, all kind of little metrics. That it's all part of that formula. And really, and this is a kind of a deep concept, but all the predictive and prescriptive analysis of data analytics is built upon mathematical models. And if the mathematical models accurately represent the real world, then we can make very accurate predictions and very accurate prescriptions of actions, based upon it. But it's all dependent on math, so that's why it's really important. Ultimately, this was their goal, to train a machine how to learn. Kind of a weird concept. An offshoot of machine learning is deep learning, right? And the goal here, right, is to take it even farther, right? And this is kind of the era that we're getting into now, that it's much more realistically human-like, that it attaches to, like, for example, right, understanding your voice, or identifying that image that we're looking at is you and not somebody else, right? Like when that guy killed the CEO from the insurance company, I mean, it was his picture that busted him, right? Yeah. Or once again, making predictions. And this is kind of interesting. So in 1943, Pitts and McCullough created a computer model based on the neural networks of the human brain. So even though primitive, they were doing that work back then. And I think, once again, I'm humbled by the fact that they were doing it so long ago, and we think that we have everything now, So it just shows you how clever they were, because they didn't have the tools that we have at our fingertips. All right, so Gen AI is a big thing, right? And a lot of us probably were intrigued by this topic and even signed up for this course because of this happening, right? In the last couple of years, this area has completely exploded. And notice the crux of this is to generate stuff from scratch, new things, right? And they're pointing out like art or music or writing or code or whatever from scratch, all based on a prompt. And part of our future, folks, right? And this is going to become part of our regular training, I think, is that we're gonna probably offer courses in how to create AI prompts correctly to get the results you want. When I did training with, we did Microsoft AI training earlier in the fall, where we had people from Microsoft teaching us how to use Copilot. And one thing that they taught us is what the mistake that most people make is they give the AI a prompt, they give it a single prompt and expect to get the result they want. And then what we learned is that first you got to tell it a story. It's like, hey, imagine the situation. All right, well then, hey, what if in that situation we created this thing, and then, oh, hey, that thing, what if we, give it this and give it that, and then this happens and then that happens, and then by the way, I want it to be blue, and whatever. And then it can like it ultimately, like a human being, sometimes you can give somebody a singular directive and they create something, or you might have to like really explain it before people get it, right? AIs are the same way. The more you give it, the better the results. Right? Very, I think, fascinating. I've experimented a lot with things in all of these areas. The one that blows me away a lot is this music one. And I just want to let you guys know this. There's services like Spotify, and I'm not trying to rank on them, maybe a little bit, right? But did you know that a lot of the content on Spotify is AI generated, owned by Spotify? And you listen to it, like you might listen to like easy jazz or something, and it's not even humans playing it, it's some like AI that generated it, and then they play it, and the streaming revenue goes to Spotify because they own the AI that created it. that's pretty weird stuff, right? Yeah, this is the kind of world we're moving into. Or how about do you watch like TV shows and go, is that background all AI? Are those people real? Because that's happening a lot now in a lot of the content we see, like in, you know, we were watching, I forget what series it was with my wife, and she was picking up on it. She goes, all that stuff in the background's AI, right? Those aren't even real people. I'm like, yep, you're on it. Like crazy, just crazy. All right. You know, why ultimately it makes life easier, right? I mean, that's kind of the conception, and true, right? Like if I'm like about to develop a lesson plan and I don't know like what to put on the lesson plan, I might go to ChatGPT and say, hey, what are some of the primary things of whatever, and it'll just give me a list, and I'll go, okay, I can work with that, and I'll make an outline, and I'll get a lesson plan going. And sometimes I've been in class and I forgot to like bring my notes with me or something like that, and like, oops. And I just go to Chat GPT and say, give me the 5 major ways to do whatever, and then give me a list. And I'm like, okay, yeah, now I know where I'm at, And it's not that I'm using it directly, but I'm using it to inspire me to do, something more efficiently, you know, and better, hopefully. All right, so keeping on moving through this, and I'm looking at the number of slides, and I'm not feeling very hopeful to get through all of them, but I'm going to try. Let's start to take a little bit of a comparison now and look at some of the differences between generative AI and conventional AI, right? So let's kind of read through this. It says, in contrast to other forms of AI, Gen AI is especially made to produce new and unique content, right? Here's some significant variations. It says Gen AI creates new content, whereas conventional AI analyzes, processes, and classifies data. Notice the difference, right? So we're not asking it to create new content. We're asking it to look at the data that we have and process it. That's what real AI, traditional AI does. Gen AI models have to have these really large data sets, all these other tools, neural networks in the background to help them create that content. So they need kind of like examples to work from is really the kind of way to look at it. Like if you tell it to create like jazz music, how does it know what jazz music is? Well, you got to give it some example jazz music. When I went to this AI conference at Northwestern Mutual in early December, and I talked to a dean from one of the schools where I used to teach. I used to teach at the Art Institute in Milwaukee. And the dean of that school is a very accomplished painter, and she said her big worry about AI is she doesn't want to put any images of her artwork online because she doesn't want AI to sample her content and then use that as a basis to create new artwork. And the Gen AI, she claims, is plagiarizing people's work. How about that for a concept? Very, very interesting. But so Gen AI models use libraries of samples. Conventional AI employs fewer complex algorithms and training models, so more math-based, basically. The Gen AI stuff looks fresh, innovative, and unexpected. Conventional AI produces more predictable output based on existing data. Right. So interesting. It's like, so how do you apply this? Gen AI benefits art, music, literature, gaming, and design. Not according to that dean I used to work with. Right. She has a very contrary opinion to that. And then conventional AI is used in banking, healthcare, image recognition, and language processing. Okay. So you can see also that there's kind of a combination here too, right? Because obviously Gen AI is using language processing as well. Right. So it can create brand new things. It seems like the possibilities are endless. Noah, I know you're a big proponent for sure. And
I'm actually curious, what do you use for music software to generate music?
For engineering music or generating?
Yeah, generating.
There's a few different websites. I can't quote you the exact URLs.
Okay.
I think one of them is like Udio, like audio without the. That's one of them that I've used. Kind of scary, but I want you to think about this really carefully, right? If you can take a Gen AI engine and ask it, for example, develop a cure for cancer, right? And it comes up maybe with an answer. What if I took 20 different Gen AI engines and asked them all the same question, but they all came back with different answers? Or maybe 10 of the answers are the same and 5 are different, that kind of thing, right? Could it, in principle, accelerate the discovery of really important things and get us pathways to amazing new discoveries? Yeah, I think that's entirely possible, but it's also where it has the possibility to get crazy. And Cabal, no, I have not tried that product, but maybe. Right. So Gen AI uses existing algorithms, creating training data for new neural networks, as you see here. Yeah, so optimizes algorithm performance and accuracy. The one thing you have to do remember about those Gen AI engines, the public-facing ones that are free. Remember what I said before during the data analytics class? It uses public-facing data to give you answers. When you use the paid version, it then goes deeper, right? You get much better answers. So Gen AI acts as a machine that designs better machines. So what if we task a Gen AI to create a better version of itself? And then now that you guys know what object-oriented programming is, we can ask it to instantiate multiple copies that do the same thing. What will be the rate of advancement? These are some of the really heavy questions, right?
We're going to hit the singularity at some point.
Yeah. Do you guys know what the singularity is?
I've heard of it.
Yeah, that's when the AI becomes aware of itself and then decides humans are inefficient and we don't need them around. That's the Skynet theory, right? Let's kind of take a look at like where things are moving now. So take a look at some of this stuff, and I think this is like some really interesting usages, right? So we have AI that can recognize images and figure out, like, for example, what's a human, what's a car, what's a bird, what's a tree, what's a house, right? We have the natural language processing. That is where we can either speak or type into an engine, have it interpret what we mean and react to it correctly, and inferring the meaning between 2, 2, and 2, for example, right? Talking about the number? Am I talking about the infinitive, or whatever? Video classification. That's a really interesting one. When I did my first round of training, the guy that taught us is a guy that works for the equivalent of the Homeland Security Department up in Canada. And he said that one of his major projects was running video classification software over airport surveillance systems to identify terrorists walking into the airport before they have a chance to cause trouble. That kind of like really weird stuff, heavy duty, like impactful types of things. Some of the ones on the bottom. So for example, tabular and time series data applications. Okay, tabular, what does that mean, folks? Spreadsheets, databases, right? So data analytics people, I told you like a spreadsheet is tabular data, rows and columns. Also like speech conversion and those types of things. They kind of break the Gen AI into these different categories, right? So you can create visual stuff or audio or text, or, for a lot of us coders, code. That's amazing, right? Most of the people that I know that are professionally coding, that make money off of it, are deeply using AI already. I have people that do like app development, software development, web development. All of them are using it to automate their workflows and really speed up the process of creation. Scary stuff you have to start to consider is that going to take our work away? Right. These are the most popular of all the virtual assistants. And I don't know how many of these you guys have tried or like to use, right? Like if you're an Apple person, you probably have used Siri. you know. I tend to be more on the Google platform. I've never tried Alexa, real frankly. I have tried Cortana, but it's off on my system. You know, I can only handle so many AI engines listening to me at once, right? You know, so you got to choose. But these are probably the four most popular ones, not the only ones, right? What's the goals of it? You know, I'll let you read that for yourself, right? And yeah, like if you do have a routine task, right? Why not use something to speed up your time? You know, if you can do that, why wouldn't you do that? If you're creating new stuff, and okay, great example. I know I've probably used this example with some of you before, but like when I did some app training last year in Arizona, and we were developing an app, but we needed some data to feed into it to see if it was working. And I could have sat there for a half hour typing up the data, or you know, we're just nope. The instructor said, no, just go to ChatGPT and say create a Python list of blah blah blah. 3 seconds later, you have it, dump it into the app, and you're testing. Right. Saving a ton of time. All right. So AI machines mimic what kind of intelligence? Humans, of course. And I'm going to skip the slide here if you don't mind. All right, let's take a look now at what really kind of separates automation from AI, because a lot of what we think is AI might actually be automation. And this is kind of one of my intentions. AI does fit into a few different categories, and a lot of people aren't aware of this. We have what we call the artificial narrow intelligence, general intelligence, and super intelligence, right? So this is kind of the thing. So the narrow intelligence is very specific to very narrow topic areas. And because it's very focused, can do it really, really well. So for example, they say emails in the inbox getting sorted into spam and not spam, right? Still some gets through, but if most of it ends up in the spam box, great, right? That's a really good example. Then there's the general intelligence, which, you know, they say involves cognitive abilities. And so they say, you know, machines that can basically do what task a human can do. And so the example they give here, here's where Jarvis comes in, right? Remember the movie Iron Man, right? And Iron Man asks him to do like stuff, and he acts like a human being and does the tasks like a person, and it, you know, does it really well. And then we have what we call the super intelligence, which is the part that scares us to death, really, which is the part that can way outperform us, right? You know, enter Battlestar Galactica, right? The machines take over and rule. Charles, you have your hands up.
Well, I guess I just was maybe, I mean, I know you didn't make this picture on the side, but like if general intelligence is supposed to be roughly a human sort of equivalent, but humans are also conscious, why is the machine being conscious considered super intelligent? Like, why wouldn't consciousness be in the same tier, right? You see what I'm saying?
Yeah, you know, there's some people that say that we already have AIs that are self-aware. Like I think that like the Google camp was saying that theirs was not only self-aware but a little temperamental and moody, you know. I really don't know the answer to that, Charles, but I think that's a very poignant question. And and right, like, you know, like who put this slide together? Well, you know, right here they tell you who did, right? If you want to follow that link and read into it. Are we there yet? Okay, the answer is at the bottom bullet. We're not there yet. The fear is that when we get there, will it take control? You know, that's a very poignant question. Very, all right. I'm going to skip past this slide if you guys don't mind. All right, so how AI differs from not AI says machine depends can be considered a critical difference between AI and not AI. And it says, you know, independent machines are ones that can solve problems independently. I'll give you kind of an example. How many of you have ever shopped at Woodman's? A lot of people, right? Especially if you live in Kenosha or up by Oak Creek or wherever. Have you ever gone there late at night? You know, and that's my favorite time to shop there. I learned that during the pandemic. So I'll go like at 11 o'clock or midnight or something. There's nobody there. They're putting all the fresh product on the shelf, but they also have a very interesting employee. It's a robotic mechanism that goes up and down the aisles, looks at every shelf, scans them, sees what products are short, and automatically orders. It's a robot stock keeper or inventory tool. And if you walk up to it and it sees you, it stops and it tries to go around you. You know, yeah, it's crazy, right? And it's autonomous. Okay, so is it really intelligent? Arguable. Is it independent? Yes, it's operating independently. There's nobody steering it. It's got software. It's got like LiDAR and sensors and lights and cameras, and it kind of figures out like where you are and tries to like not run into you. And it's also smart enough to go up and down the aisles and figure out what products are there. Look at the product, look at the sticker on the shelf, take the inventory and say, order a case of, you know, cat litter or whatever. And it just does it automatically. Does it have cognitive abilities? I'm going to argue no, but the fact that it can navigate itself is pretty interesting. You know, so there are a lot of apps that are confused as being AI applications that really are not. So here's some examples, right? Like I have an OBD reader that I sometimes plug into my car, right, to see like what like engine codes it's throwing. I don't know if you guys have ever done that. Usually you have to go to a mechanic to have one of those, but now you can buy them for like 20-30 bucks. And by the way, it's a smart buy, because rather than trusting your mechanic to tell you what the code is that needs to be fixed, you can look it up yourself and see if he's telling you the truth or not. Okay, is that AI? No, it's not. What is it doing? It's just reading the computer on the machine. The computer on the machine is reading the error codes from the devices. It's just an algorithm. Oh, look, the mass airflow sensor failed. It throws an error code. You read it off the computer, and then you know what part to change. And that's not AI. And the other examples here are not AI either. They're just technological tools that can feed into AI, but it's not intelligence. And I think this next series of slides is pretty cool, real frankly. They start talking about, decision making. For example, AI decision is based on learning from experience. Not AI decisions are based on certain predefined steps or rules. So it's just an algorithm, like Python code or something, right? And the point here really is, as you go through these slides, and you can read them for yourself, is to separate between, like, is it truly intelligent? It's going to perform a certain way. Is it just really well written software? This is back to my contention again. It's probably not AI, but it can appear to be AI, right? Even the voice assistants on our phone, well, they are starting to be AI powered now. But like when Siri first came out, it wasn't AI powered. It was just a really well written piece of software that when you said, hey, open the Safari browser, it knew how to do that. It's not like it's really actually smart. It just recognized the word Safari, for example. The thing that I do agree with on some of these slides, like for example, using Gen AI, it does spark a lot, right? Like, so if I can write like a piece of code, or I can, like, for example, I can say, hey, I'll give you guys an example. I was working with a Google spreadsheet. I'm trying to find the right browser window here. Sorry, let me just bring up ChatGPT. Let's see what account I'm in here with. Well, all right, here you go. I needed to write a formula in my spreadsheet to compare one column to another to see if the data was matching. And this is for a long list of items, like hundreds of items. And I was like, what's the syntax for that? And I didn't want to look it up. So I just came in here, asked to type it up, dropped it into the spreadsheet, copied the formula down, boom, it was working. Right? Is that cheating? It's not that I've never worked with spreadsheets before. I would have eventually figured it out on my own. But in the time it took me to figure it out, I was already completely done with the task that I needed it for, right? Rather than wasting the time. So these are the kind of little productivity boosts that we get. So, okay, this isn't necessarily a new idea or concept, but it sure is part of the other aspect here, which is, I mean, really, it just helps me work a whole lot faster. And I am being mindful of the time here. We're clearly not going to make it all the way through the slideshow, but I'm going to try to get as far as we can. So I'm going to try to hit a few more slides before we call it a wrap. All right, so remember when I was talking about the Adobe products and when they first launched their AI tools? Here's an example. And back then when they first pushed it out, they did call it Firefly. And they released it on a very limited basis. Eventually that turned into a product called Adobe Express. And now it's already become really commonly used. So you guys noticed that what they just did there? Yeah. That's how powerful it is. The first time I saw that, I was like, shut the front door. I'm all in. I'm already a subscriber. They didn't up the subscription fee or anything. I don't have a lot of usage for it, but man, just the possibility, just that I have it at my fingertips if I want it, just blows my mind. Okay, so if you can do that with just Adobe software, that's like $20-$30 a month or $50 a month. Okay, now I understand why I watch something on Netflix and I don't believe that any of the stuff in the background is real. Heck, I'm not even sure if the actors are real. All right, do you ever watch like This Is Us and they have like the people when they're old and they're young, and how did they do that? It's not just makeup, folks. It is not just makeup. It is technology pushing the boundaries. Here's another example, right? Right. So this is an example. Like you draw around something. Yeah. So this is a quiz. I'm going to skip over the quiz. I'm going to cap it here. And I think probably what I'm going to do next time around is, because we won't have any of the syllabus stuff to do, is we'll carry on from this point. What I would encourage you guys to do is look through the rest of this on your own and read it so we can have some good conversations about it. And then you can start thinking about doing the homework, which will be due 2 days after next session's class. Right. So I'm going to can this video here. This video ends here. So this will be part 1. Part 2 is forthcoming.